A very good morning to my lecturer, Dr. Kok and Dr. Ng. Now I would like to present about linear programming. So, what is linear programming? Linear programming is a mathematical method that is used to determine the best possible outcome or solution for a given set of parameters or list of requirements, which are represented in the form of linear relationships. It is also one of the simplest ways to perform optimization. It makes a few simplifying assumptions to help us to solve some very complex optimization problems. What is the use of linear programming? Linear programming enables us to obtain the most optimal solution for a problem with given constraints. For example, we can formulate our real-life problem into a mathematical model. Mathematical model consists of three elements. First is decision variable, second one is the objective function, and the third one is constraints. What is decision variable? Decision variable is the quantities to be determined. For example, we let something to x and let something to y. What is objective function? Objective function represents how each decision variable will affect the value that needs to be optimized. Why we need to find the objective function? We need to find the objective function to maximize or minimize something, such as the cost of a project, a production quantity, or profit value. Constraints. Constraint represent how each decision variable will use limited amount of resources. The linear constraint is the linear inequalities or equation or restriction on the variables of a linear programming problem. Now we look at the application of linear programming in our daily life. Nowadays, we are all impacted by the COVID-19 pandemic. Many of us had lost jobs. Thus, Bon Abina would like to sell some yam cakes to earn some money to help support family financial needs. She decides to sell two types of yam cake, which is yam cake A and yam cake B. Both the yam cake require yam and rice flour only. Each unit of yam cake A requires 200 grams of yam and 400 grams of rice flour, while each unit of yam cake B requires 300 grams of yam and 200 grams of rice flour. Bon Amina has a total of 5 kilograms of yam and 8 kilograms of rice flour. On each sale, she makes a profit of 2 ringgit per unit yam cake A sold and 3 ringgit per unit yam cake B sold. Now, she wants to maximize its profit. So how many units of yam cake A and B should she make respectively? To solve this question, we need to apply the model of linear programming. There are 3 steps in formulating linear programming model. The first step is to identify the decision variable. Second step is to identify the objective function, and the third step is to identify the constraints. After we identify the 3 mathematical models, we need to solve 2 variable linear programming by graphical method, which involve 2 steps. The first step is the determination of the feasible region that defines all solution space of the model. The second step is the determination of the optimum solution from among all corner or extreme points in the feasible region. Now, we need to solve this question by applying the linear programming model. First step, we need to find the decision variable for the question. For this question, we let the total number units of young cat A to be produced equals to X, and we let the total number of units of young cat B be produced equals to Y. Second, we need to identify the objective function for the question. From the question, we know that Puan Aminah want to maximize its profit. Thus, we need to find the maximized Z, which is the profit, the maximum profit Puan Aminah can earn. From the question, we know that 1 unit of young cat A, Puan Aminah can earn 2 ringgit from when you sell 1 unit of young cat A. When she sell 1 unit of young cat B, she can earn 3 ringgit. Thus, our maximized Z equals to 2x plus 3y. Third, we need to identify the constraints. From the question, we know that Puan Aminah have 5 kg of yam, and to make young cat A, Puan Aminah require 200 gram of yam, and for young cat B, she require 300 gram of yam. Thus, the first constraint we can determine is 200x plus 300y equals to 5,000, less than or equal to 5,000. The second constraint we can determine from this question is the rice flour. To make young cat A, Puan Aminah require 4,000 gram of rice flour, and for young cat B, 1 unit of young cat B, she require 2,000 gram of rice flour, and she only have 8 kilogram of the rice flour. So the second constraint is 400x plus 200y equals to 8,000, less than or equals to 8,000. At the same time, x and y must greater or equals to 0. The fourth step, we need to determine the feasible region that defines all solution space of the model. Before we determine the feasible region, we need to solve the equation, 3 equations, 2 constraints, and 1 maximized Z. The first equation, when x equals to 1, y equals to 16, and when x equals to 22, y equals to 2. We can get 2 coordinates from here, and after we plot these 2 coordinates on the graph, we can get this line. Next, the second equation, when x equals to 0, y equals to 40, and when y equals to 0, x equals to 20. When we plot these 2 coordinates, we can get this line. For the third equation, when x equals to 0, y equals to 20. When y equals to 0, x equals to 30. After we plot these 2 coordinates on the graph, we can get this line, which is the line to determine the maximized Z. So We can determine the feasible region because the first equation and the second equation, we know that it is less than or equals to. So we determine the less than or equals to, so the feasible region is here. Then to determine the maximized depth, we need to see this line. We can move down this line until it touches the maximum point of the feasible region. That is 17.5 and 5. This is the point that to determine the maximized depth. The fifth step is the determination of the optimal solution from among all the corner or extreme point in the feasible region. Thus, the maximized depth is equals to 50 after we substitute the maximum point, that is 17.5 and 5 into the equation. So we can conclude that Wang Amina needs to met 17 unit of young cat A and 5 unit of young cat B to achieve the maximum profit. In conclusion, linear programming can help Wang Amina to overcome the problem of financial need during this pandemic because she can determine the number of young cat A and young cat B she needs to met so that she could earn a maximum profit through the help of a mathematical model. From the maximum point 17.5 and 5, we get to know that Bo Amina should match 17 young cat and A and 5 young cat B to achieve a maximum profit. So let us recall back how to formulate a linear programming model. So the first step is we should identify the decision variable, objective function, and also the constraints. Second, we need to determine the feasible region that defines all solution space of the model. Last, we need to determine the optimal solution from among all the corner or extreme point in the feasible region. That's all from me. Thank you.